record it. Now, if you still recall, last time we spoke about the moving average processes, where we started by introducing the first order moving average or moving average of order 1, where I told you that all the moving average are always stationary. However, they are not always invertible. And then we try to check whether the moving average of order 1 is invertible or not. Then we use the condition where, because we have only one parameter, theta, our main aim is to check whether theta 1, the absolute value of theta 1 is less than 1. If the absolute value of theta 1 is less than 1, therefore, the process xt, or the process of moving average of order 1, is invertible. But if it's not less than 1, the absolute value of theta 1 is not less than 1, therefore the process is not invertible. Then we continue to find the autocovariances and the autocorrelation functions of the same process. No, not yet. I have not yet presented anything. I'm just trying to remind you what we did last time. Okay. Now, today we are going to continue with our moving average processes, but in this time is for order 2. So let me just go to the screen. You can't hear me? Yes, everyone?
Yes, sir.
You don't hear anything? Come
We
again?
can hear you, sir.
I can hear you, sir.
But,
I can hear
okay,
you.
but okay, thank you very much. Okay, it's fine. Let's continue. Okay, let me just go to the screen window journal so that you can start discussing the lecture of today. There we are. Okay, lecture number 7. It's about second order moving average, or moving average of order 2. Lecture number 7. It's just a continuation of a moving average. So, but this time around, we're going to deal with the moving average of order 2, or the second order moving average. We call it the second order moving average, or moving average of order 2. Okay. The question is, what is the second order moving average, or moving average of order 2? So we can define it in this way. A process xt is said to be let's say second order moving average, or simply moving average of order 2 if xt is equal to zt plus theta 1 zt minus 1 plus theta 2 zt minus 2, where zt is always a white noise with mean 0 and variance sigma squared z, and I is ranging from 1 to 2, are real valued constant. Okay, so this is how we define the moving average of order 2 or second order moving average. It's a process which is defined by xt equal to zt plus theta 1 zt minus 1 plus theta 2 zt minus 2, where zt is always a white noise with mean 0 and variance sigma squared, and theta 1 and theta 2 are real valued constant. Like I said, moving average of order 2 is always stationary, but it's not always invertible. So we have to check the invertible conditions of moving average of order 2. So let's check the invertible conditions of moving average of order 2. So invertible conditions. So
Sir, can
this
you
time
please
around,
go back to the Tanzania?
oh, okay. So this is the real value constant, because they're true. Okay.
All right, thank you.
Okay, sure. So now we just want to check the invertible conditions of a moving average of order 2. So we have got 3 conditions. The first one, we just want to check if theta 1 plus theta 2 is less than 1. That's the first condition. Check whether theta 1 and theta 2 are less than 1. It's less than 1, sorry. Condition number 2, check if theta 2 minus theta 1 is also less than 1. That is the second condition. The third one and the last one, you have to check the absolute value of theta 2, whether is it less than 1. Now, what does that mean? Those conditions helps us to check whether the process is invertible. In other words, if you check the first condition, you find that theta 1 plus theta 2 is not less than 1. So we just conclude that the process is not invertible. However, if you check the first condition of theta 1 plus theta 2 to be less than 1, you have to continue to condition number 2. Theta 2 minus theta 1 must be less than 1 also. Then, if the 2 holds, so you have to continue to the third one. The absolute value of theta 1 to be less than 1. All those conditions must be held. If one condition fails, therefore the process is not invertible. All those conditions must be fulfilled. Are we together? So now you can just use these type of conditions, or use the other method that I introduced last time. The one that you have to write your process in backshift operator. From there, equate to 0, and we find the roots or factors. If the values are outside the unit cycle, therefore the process is invertible. If the root is not outside the unit cycle, so the process is not invertible. Because in this case, we are dealing with two roots. So here you're going to have two roots. All of them must be outside the unit cycle. Okay, let me just quickly go to that one. Method number 2. You have got xt, which is equal to zt plus theta 1, zt minus 1 plus theta 2, zt minus 2. Okay, then you write this process in backsheet operator. How do you do that? This is equivalent to 1 plus theta 1 b plus theta 2 b squared, close brackets, then zt. So this is the backshift operator of moving average of order 2. Then after doing this, then you equate whatever within the brackets to 0. So I can continue to the next page, isn't it? So if you just go.
No, sir.
Not yet. You're slow in writing. So this is method number 2 if you don't want to use the first one. So you have to write the process in backshift operator, which I did. I hope you are done. Okay. So then you take everything within the brackets. I think it's this equivalent to 1 plus theta 1b plus theta 2b squared. Then you equate it to 0. So as you see, it's a parabola. Obviously, you're going to have two factors. Okay, it's either your value is going to be b equal to something, okay, or another b is going to be equal to something. Actually, you're going to have two values, two factors, so to speak. Then you check all those values, whether they are inside or outside the unit cycle. Okay, so therefore you have your unit cycle there. Okay, minus 1, 1, 1, and 1. This is a unit cycle. So you just want to check these values. Just want to check this one, this value, b equal to something, and you have to check this one, this value b equal to something. Because there are two roots, so all of them must be outside the unit cycle. So the value of the first one is supposed to be outside the unit cycle. Again, for the second one, supposed to be outside the unit cycle. If all of them are outside the unit cycle, therefore the process xt, which is a moving average of order 2, is invertible. However, if one value is inside, another one is outside the unit cycle, therefore the process is not invertible. Again, if one value is on the cycle and another one is outside a unit cycle, therefore the process is not invertible. If all those two values are on the cycle, therefore the process is not invertible. The process to be invertible, all those two roots or two values must be outside a unit cycle. I think it's clear. Any question before I proceed? None, isn't it? Okay, now it's up to you. You can use the first method to check the conditions, Or if you don't want that one, you can use the second one, where you have to write the process in backshift operator, then you find the vectors, then you check those vectors whether they are outside the unit circle or not. If all of them are outside the unit circle, so the process is invertible. Okay. Now let's go to the autocovariance functions, because now we are sure that the process is what? It's always stationary. So we can calculate the autocovariance and autocorrelation functions. So now let's go to the autocovariances. Okay, sorry, let me use this one. ACVF. ACVF stands for autocovariance functions of xt. Which xt? Moving average of order 2, which is defined by what? By zt plus theta 1, zt minus 1, theta 2, zt minus 2. So now we just want to find the autocovariance of moving average of order 2. So where do we start? Start by finding the expected value of xt, which is equal to the expected value of zt plus theta 1, zt minus 1 plus theta 2, zt minus 2, close brackets. So the question is, what is the expected value of zt plus theta 1, zt minus 1 plus theta 2, zt minus 2? Remember, zt is a white noise with mean 0 and variance sigma squared z. Whatever that, the expectation of whatever that contains zt is 0. So that is why the expected value of xt now is going to be equal to 0. Are we together? Then from there you find the gamma 0. Gamma 0 is the variance of xt, if you just want to use that method. Or gamma 0 is equal to the curve of xt and xt. Now let's use the curve of xt and xt. That's our gamma 0. You can use gamma 0 to be equal to var of xt, or gamma 0 equal to curve of xt. They are going to give you the same answer. Yes.
I had a network connection. Why
Mm.
did you say it's equals to 0?
Oh, because it has been defined that zt is a white noise with mean 0 and variance sigma squared z, if you still recall.
Yeah.
Because is from this condition, if I can take you back. Yes, from this condition, we're applying this condition. So that means the expected value of anything that contains z is 0.
Okay.
That is why we're using 0 there.
Okay.
Now, gamma
Thank you.
0 is
Sir,
equal to the curve of, yes.
why are you calculating for gamma 0?
Why? Why
Why
do
are
we
you
calculating
calculating gamma 0,
Yes,
not
we're
gamma?
calculating gamma 0 because we want to find the autocovariance functions of xt, which is the moving average of order 2. To do that, you have to calculate gamma 0, gamma 1, gamma 2, up to gamma k. That is the autocovariance functions. I don't know whether you got the answer.
Okay.
Okay. Now, you can use gamma 0 equal to curve of xt or gamma 0 equal to var of xt. You're going to get the same answer. So in this time around, we're going to use curve of xt. What is the meaning of curve of xt? Curve of xt is the same as curve of xt is zt plus theta 1, zt minus 1 plus theta 2, zt minus 2. That is curve, that is xt. So it's going to be curve of zt plus theta 1, zt minus 1 plus theta 2, zt minus 2. That is xt. So another xt is going to be again zt plus theta 1, zt minus 1 plus theta 2, zt minus 2. Then you close the brackets. So we just want to find the curve of that. So now we have to check whether they are independent or not. Now, if you check this one and this one, they're not independent, and this one and this one. So you group this one and this one first, then this one and this one, then this one and this one. So you're going to get what? The curve of ZT, ZT. It's the first one. Then you said plus theta 1 squared, the curve of ZT minus 1, ZT minus 1. Then you said plus theta 2 squared, the curve of ZT minus 2, ZT minus 2. Okay. So what is the curve of ZT, ZT? The curve of ZT, ZT is like the variance of ZT, and the variance of ZT is equal to sigma squared Z. So the next step, so we have to take it to the next page. Can I go there?
Not yet.
Wait,
sir.
sir. No.
Kane adimal slide luje.
Eh? Come again?
Sir, I don't understand why there is theta square.
Oh, theta square. Here, let me show you. This theta 1 squared is coming from this one. Isn't that you are taking this one and this one? You're taking this, the curve of this one. So when you take the curve of this one, you multiply theta 1 and theta 1. Outside, take it outside, then you find the curve of ZT1, ZT minus 1, ZT minus 1. So theta 1 times theta 1 is theta 1 squared there. Then the curve of what? ZT minus 1 and ZT minus 1. So that is why I'm using this one. The same applies to theta 2. It's theta 2 times theta 2. Take it out as a constant, theta 2 squared, then curve of ZT minus 1 and ZT minus 1. That's why I'm having something like that.
All right, sir, thank you.
Okay, then our gamma 0. So our gamma 0 now equal to 1 plus theta 1 squared plus theta 2 squared, close brackets, multiplied by sigma squared Z. Okay. So that is a gamma 0. Then you continue to gamma 1. So gamma 1 will be equal to the curve of
Sir, I didn't understand how
yes.
you got number 0.
Sir,
It's coming from this one. Can you see the last part there? Curve of ZT and ZT is the same as the var of ZT. And the var of ZT is sigma squared Z. So that is why we substitute this one by sigma squared Z. Then from there, there is a step that I just omitted here. Actually, we were supposed to have here sigma squared Z plus theta 1 squared sigma squared Z plus theta 2 squared sigma squared.
sir,
We're supposed to have that step up there.
sir,
Sir, can you
Yes.
slide it?
Sir,
Yes, Tom.
are you saying the variance of ZT, which is the same as the curve of ZT is the same as the variance of ZT minus 1 is the same as the variance of ZT minus or ZT minus 2, which in general
Yes.
we can
Yes.
express it in the variance of ZT of K, which is equals to 1. Are you saying the variance of ZT of K is 1?
Variance of ZT of K. What do you mean when you say variance of ZT? Oh,
Variance of
ZT minus K.
ZTK, the variance of ZTK, are you minus K? Are you saying is equals to 1?
I'm not saying it's equal to 1.
Because
I'm saying
can you please go to the previous page? I want to show you something.
okay. Yeah.
Here you said the curve of ZT, you substituted by 1. The curve of ZT minus 1, ZT minus 1. You are left by theta 1 squared, which means you also substituted by 1. Here you said the curve of ZT minus 2, ZT minus 2. You are left with theta 2 squared. You also substituted by 1. So in general,
Oh,
are you saying the
okay.
curve of ZT, like of ZT minus K and ZT minus K, is equals to 1, which is the same as the variance of. Are you saying that? Because it
Let me
means
just
that
explain.
these ones explain why we got the 1. It means that these
Yeah.
three are
Let me
equal.
just go there.
We got the,
Okay,
yes.
it's fine. It's fine. Let me just go there. You see this last step. So let's just go to the next one. Here, I said this is equal to sigma squared z. Can you see the upper part here? This one. Can you be able to see that one?
Yes, we can see that
Can you
part.
please write it clearly, sir?
Eh? Oh, okay, let me just write it nicely so that you can understand.
Yeah, right hand.
If you recall, I said gamma 0, okay, it's equal to the curve of ZT, isn't it? Plus theta 1 squared, the curve of ZT minus 1, ZT minus 1, okay? Plus theta 2 squared, the curve of ZT minus 2, ZT minus 2, okay? So now, the curve of ZT, I said it's like the variance of ZT, which is equal to sigma squared Z. So this one now, we can substitute it by sigma squared Z. Are we together? So plus, the same applies to this one. We are going to have theta 1 squared. Then the curve of ZT minus 1, ZT minus 1 is the same as sigma squared Z. What we're saying. Okay? Plus the last part, theta 2 squared. The curve of ZT minus 2, ZT minus 2 is like sigma squared Z. That's what we're saying. So now, if you check, you can find the common factor, which is what? Sigma squared Z, isn't it? So you're going to get 1 plus theta 1 squared plus theta 2 squared. Then close brackets, then you multiply by sigma squared Z. It's what it's supposed to be. You get that?
Oh, so it means the curve of ZT minus K is equals to sigma squared Z.
Minus K. It depends to the whether those variables are independent or not. If the variables are
If you
not
can make
independent, Eh?
If you can make it the curve in terms of the expectation, you will understand it better, or why this thing is all happening like this.
Oh, it's the same thing. You can use curve or use expectation, you're going to get the same thing. So we are going to use expectation when we will be dealing with the auto-regressive. Here we are dealing with the moving average. So that is why we use curve, so that you cannot get confused. Here, because we are dealing with the moving average, we are including curve. When we will be dealing with the expected auto-regressive, we are going to use the expected value. But anyway, they are the same. They are having the same qualities, the same what do you call it? Yes, they gave you the same answers, so to speak. So can I go to gamma 1? Yes or no?
Yes, sir.
Okay. Let's go to gamma 1. We'll understand it better there. I hope so. Gamma 1 now is equal to the curve of, okay, xt minus 1. That's gamma 1. Okay. Then, which is equivalent to the curve of xt again is the same as zt plus theta 1 zt minus 1 plus theta 2 zt minus 2. Okay. What about xt minus 1? Where there is t, you put xt minus 1. Where there is xt minus 1, you put zt minus 1, you put zt minus 2, and so on. So you're going to have zt minus 1, the first one, plus theta 1 zt minus 2, okay, plus theta 2 zt minus 3. You get that? So let me just go and rewrite it nicely on the next page. So it's gamma 1 equal to the curve of zt plus theta 1 zt minus 1 plus theta 2 zt minus 2. Okay. So xt minus 1 is going to be zt minus 1 plus theta 1 zt minus 2 plus theta 2 zt minus 3. Okay. So now you have to check the independence now. So this one and this one are not independent. So their covariance is going to give you something, and even this one and this one are not independent. So that is why we are grouping them together. So at the end of the day, you're going to have theta 1, okay, which is this one. Because it's a constant, take it out, then you write curve. Curve what? Zt minus 1 and zt minus 1. Okay, now we're done with the first one. Then you said plus. Okay, you take theta 2 zt minus 2 and theta 1 zt minus 1. Then you multiply theta 1 and theta 2. You're going to get what? Theta 1, theta 2, isn't it? Then include the curve.
Sir.
The curve of what? T minus 2. Yes.
Okay, so
Yes.
you are saying you are saying since zt minus 1 and zt minus 2, they are not equal, but they have the same coefficients, we don't square because they are not the same, right?
Come again. Z and what?
Okay, maybe I'm mistaken. Okay, now I see.
You see it? So we are grouping those that are the same. zt minus 1 and zt minus 1, zt minus 2 and zt minus 2, because they are not independent. So their covariance is going to give you something. But there are those that are independent. For example, zt and zt minus 1, they are independent. So their covariance is going to give you 0. So that is why we didn't include them there, because we know that we are going to get 0, 0, 0. Okay. So now, theta 1 curve of zt minus 1, zt minus 1. It's like the var of theta 1 var of zt minus 1. And var of zt minus 1 is sigma squared z. So the first part is going to be theta 1 sigma squared z. I think we're together. So theta 1 times theta 2 curve of zt minus 2, zt minus 2. Curve of zt minus 2, zt minus 2 is like curve var of zt minus 2. And the var of zt minus 2 is like what?
Say,
Sigma squared z. Yes. So now we are going
say,
to have theta 1, yes, theta 2. Yes, ask.
You are too fast, sir.
Come again?
can you hear me, sir?
Yes, I can hear you now.
I think you left out the last part of theta 2 zt minus 3.
Yes, theta 2 zt minus 3. That one you can combine with zt or theta 1 zt minus 1 or theta 2 zt minus 2. You are going to get 0 because they are independent. So their covariance is 0. Oh, I left another step there. I thought maybe you are understanding. So actually we're supposed to have something like this. Let me just say we are including this step here. Okay, that you can understand it better. So here you have got curve of zt, and then you combine with zt minus 1. So you're going to have curve of zt and zt minus 1, isn't it? You take this one and this one. Okay, then you do the same, but it's too long, because when you combine all those things, you're going to have a long thing, but at the end of the day, the curve of independent variables, they are going to give you 0. Like this one, curve of zt and zt minus 1 is going to give you 0. So that is why we left it out there, because it's going to give us 0. The same applies to the curve of zt again. You can take zt again, the curve of zt and theta 1 zt minus 2, this one and this one. Okay, because you are having the constant there, so that means you're supposed to have a constant as well. Because here you're having a constant here, so you take it out as theta 1, then curve of, you take this zt and you take this zt minus 2. You see now, this one and this one are independent, so their covariance is going to give you 0. So that is why we left it out, because it's going to take us take a space anyway. Okay, so the same applies to, I'm giving you the example with zt. We combine zt and this one, zt and this one. We're going to combine zt again with this one. All of them, they're going to give you 0 because they're independent. So that means you're going to have plus zt and theta 2 zt minus 3. So you take theta 2 outside as a constant. Then you said curve of, okay, zt and what? Zt minus 3. That is why you are saying we left zt minus 3 there. Then you close it. You see now, these two, they are independent. So their covariance is 0. So the whole thing is going to be equal to 0. So that is why we left them out. All those that are giving us zeros, we left them out. And then we consider only those that give us something, or sigma squared z. So that means this is not the only thing. So you have to combine again theta 1, this one, and ZT minus 1. ZT minus 1, so obvious is there. This one is there because their covariances are not giving us 0. They are giving us what? Sigma squared Z. So that's why we're having it here. So, but if you combine this one, okay, and this one, they are independent. So the covariance is going to give us 0. So that is why we left it out. Okay, so coming to this one again and this one, they're independent. So their covariance is going to give us 0. So that is why we left it out. Okay, then you're done with this one. Then you come to this one. So this one and ZT minus 1, their covariance is 0. The covariance is 0. So that's why we left it out. So this one and this one, you see now, that's why we included it here, because they are not independent. So their covariance is giving us what? Sigma squared Z. Okay. So that's why we included it here. So
Sir,
again, yes.
I'm lost now. Can you do?
Say,
Do them I wanna go.
Everyone was lost.
Okay,
say,
okay. Can you allow me to go back to,
say,
let's go back to this point, this one. Let me just delete everything and restart afresh,
He's not the only one
including
who's
everything.
lost.
say.
Huh?
Before I go back to the point, can I please explain? Maybe they might understand.
Yes. Okay.
Okay, what they're saying is that whenever we're using two independent variable, we're taking their curve zt and zt
Yes.
minus
Yes.
k, where zt and zt minus k are independent, we'll always get a curve of 0. So we don't have necessarily to take two independent variable and find their curve, because we know it's always 0. You remember from mechanics first year when we are doing dot product, when we are dotting I and K, I and J, two independent, we're getting 0. So we're only dotting one of the same. So here we use the same strategy. We find the curve of ZT and ZT, which are the ZT and ZT are the same. But whenever we find the curve of
Yes.
ZT and ZT minus K, where ZT and ZT minus K are not the same, are independent, the curve will always be 0. So we don't have necessary to write them. So we eliminate them since it's 0.
Them
Hopefully you
down. Yes.
understand.
Yes.
Oh, sir, what
Sir,
I'm saying
Thank
is
you
that
very much. I
say
think you
omitted
explained
some
it
of the
nicely.
terms that are supposed to be here because they are zeros. Manga,
I can't hear you because it's that
Oh,
one person at a
okay,
time,
what
so
manga
that I
is
can understand. I can't hear you. Salai? It's broken.
while she's connecting, can I ask this question?
Yes. Yes.
Is it a must to write all the steps, or I could just write the one that will give me values, leave the one which
Yes.
will
We
give
need.
me Z?
No, don't write everything. That is why I omitted some of the steps, because they are taking. Actually, we are wasting our time by writing them down, because we know that they are going to give us 0. So just write whatever is going to give you that we want. So those that are giving us 0, just leave them. So that is what I was doing there.
Okay, no
so
problem.
in a
Means you
test,
won't be deducting marks.
only them.
I won't deduct marks. I won't deduct marks because 0 is 0, so it's not 0 there. Yes. So we didn't have to write everything. So that is why some of the steps were skipping them. So, but anyway, because there are those who don't understand, so I went back again and restart again nicely, step by step. But normally, some of the steps you have to omit them because they are just consuming your time. Now we're together. So can we continue, or is there anyone who don't understand? Guys, are you still there? Are you still there or I'm alone?
Yes, continue, sir.
Anyone? Okay, thank you very much. Let's continue. So I wrote many things there. It's mixed up now. I can't see what is which. Theta. Okay, now this is the answer that we're looking for. Yeah, let me show you. So this is the answer that we're looking for. We are here. So the rest I was trying to explain so that you can understand it. So our gamma 1, let me just go to the next page. So our gamma 1 is equal to theta 1 sigma squared z plus theta 1 theta 2 sigma squared z. That's our gamma 1, isn't it? So even here, you can find the common factor, which is theta 1, open brackets, 1 plus theta 2, close brackets, sigma squared z. Are we together? So this is our gamma 1. So we have calculated gamma 0 and gamma 1. Now let's go to gamma 2. Gamma 2 is equal to the curve of xt plus 2. Okay, which is equivalent to the curve of zt theta 1 zt minus 1 theta 2 zt minus 2. Okay, and then zt minus 2 theta 1 zt minus 3 theta 2 zt minus 4. Then close the brackets. So okay, so we are going to consider only this one. The rest are zeros. We're going to consider only these two. The rest are going to give us zero, so we don't bother by writing them down. So that means we are going to have theta 2. Sorry, let me use this. So we're going to have theta 2, which is this one. Okay. The curve of zt minus 2, zt minus 2. Okay. So, and this one is equivalent to what? To theta sigma squared z. So gamma 2 is equal to theta 2 sigma squared z. Okay. Then you go to gamma 3. Gamma 3 is equal to the curve of xt minus 3. Can I go to the next page, please?
Yes, sir.
No,
Okay.
sir. No, sir.
No, sir. We're still copying.
Can you please?
No.
Yeah, we are still copying.
How far are you?
Second step before the final answer.
Sir, can you slow down? Can you please slow down?
I'm fast.
Sir, can you please proceed?
Yes, yes.
Karvat Baba understand that the moment they understand,
No,
so can you
no,
please
no,
proceed?
because you understand, doesn't mean that you understand. We're still copying.
That's unfair.
You can write on your own. In exam, you are going to write on your own. You understand? Can you please proceed?
Gamma 3.
Whenever all of it worship.
Okay, understood. Okay, please. Oh, just
Sir.
curve
When
of
as man ga araswan lu and when I yes to understand, but then troller na rin mura understand the just say educated back. How?
xt
Yes,
minus 3.
copying.
You're still here?
Yes, the last step.
Okay.
Yes, sir. We're still there, man.
You're done?
Yeah.
Okay, thanks.
No, sir.
So
No,
now
sir.
let's go to gamma 3. Gamma 3 is equal to the curve of xt minus 3, which is equivalent to the curve of
Gamma 3 is 0, sir.
zt. Yeah, obviously it's going to be 0 because all of them are what? Are independent. So, but let me just show this step, then we go to 0. Theta 1 zt minus 1, theta 2 zt minus 2. Okay. Zt minus 3, theta 1 zt minus 4, theta 2 zt minus 5. You see, this one obviously is going to give you 0. All of them are independent. Okay. The same applies to gamma 4. It's going to give you 0. Gamma 5 is going to give you 0. So now we just want to generalize it to gamma k, which is the curve of xt minus k. Okay. It's equal to what? 1 plus theta 1 squared, theta 2 squared, sigma squared z. Okay. For what? For k equal to 0. Okay. And again, theta 1, open brackets, 1 plus theta 2, sigma squared z. For what? For k. And again, theta 2, sigma squared z for k equal to 2. And the rest are zeros. That's it. That is our autocovariance function. So this is how we calculate the autocovariance function. From autocovariance function, you calculate the autocorrelation functions. But immediately when you got the autocovariance function, it will be simpler for you to find the autocorrelation functions. So any question before we go to autocorrelation functions?
Sir. So on the otherwise, they can be greater than 2.
Yes, you can just say 0 greater or equal to 3 or 0 equal to k greater than 2 or 0 otherwise. It's the same thing.
Say on the the one with theta can I put theta and sigma squared z at the same time on the same place?
Which part are you talking about?
The one for generalizing. Can I put theta 1 and sigma squared z at one place rather than placing theta 1 first? And
Oh,
then
that one is not. It's not a problem. The order is not. It's not a problem there.
all right.
You can maybe start by writing theta 2 plus 1, then you close the brackets, then theta 1 sigma squared z, or maybe just try to expand it and say theta 1 sigma squared z plus theta 1 theta 2 sigma squared z. It's the same thing.
All right.
Yeah, the order is not important there. But then can we go to autocorrelation functions?
Yes.
Okay, thank you very much. Let me just go there. Autocorrelation functions is ACF for xt, which is defined by zt, theta 1 zt minus 1 theta t minus 2. So here we are finding the ACF. ACF stands for autocorrelation functions. If you still recall, I said the autocorrelation function at like 0, in other words, rho 0 is always equal to 1. So you don't have to calculate that one. From the property, rho 0 is always equal to 1. So what about rho 1? Rho 1 is equal to gamma 1 over gamma 0. Okay. And gamma 1 is equal to what? Theta 1 open brackets 1 plus theta 2 close brackets. Okay. Sigma squared z. Then you divide by what? 1 plus theta 1 squared theta 2 squared. Sigma squared z. Now you can cancel sigma squared z there. So you can cancel this one and this one. Then we're left with theta 1 open brackets 1 plus theta 2 divided by 1 plus theta 1 squared plus theta 2 squared. That's autocorrelation functions at leg 1, rho 1. Now you go to autocorrelation functions at leg 2, rho 2. It's gamma 2 over gamma 0. Okay. And gamma 2, if you still recall, is theta 2. Then you divide it by what? 1 plus theta 1 squared plus theta 2 squared. So that is the autocorrelation functions at rho 2. At leg 2, sorry. Rho 3 is going to give you 0. Okay. The same applies to rho 4. Therefore, you have to generalize it. So when we generalize it, so you are going to have rho k. Okay. First one is going to be 1 for k equal to 0. Okay. And the second one is what? Theta 1 divided by theta 1 squared, theta 2 squared. For what? For k equal to 2. So for k greater than 2, or 0 for k greater or equal to 3, or 0 otherwise is the same thing. So this is the autocorrelation functions at leg k, rho k. So this is how you calculate the autocorrelation functions. Any question before I go to the real numbers now? Isn't that last time you asked about how do we calculate autocovariances and autocorrelation function using the real numbers? So we're going to do that immediately after this one. So any question? So remember, you can calculate the autocovariances using autocovariance generating function method. You still remember that one? Where you have to use gamma b, which is equal to psi b inverse multiplied by sigma squared z. So you have to know how to use that method. And again, you're going to get the same answer. Autocovariance function. Autocovariance generating function method. The one that I introduced last time. This one. Let me just remind you this one, this method. Gamma B, this one, side B inverse multiplied by sigma squared. Still remember this one? And I said you have to write your process in backshift operator. Then after writing it in backshift operator, you just take everything and substitute side B and side B inverse. You simplify, then from there you get your gamma zeros, gamma 1, gamma 0, gamma 1, and so on. Then at the end of the day, you are going to get the same answer as what we got for autocovariances. So this method is very important because I might ask you to use it. And if you don't use it and use that other one, you get 0. So you have to know it. So I want you to go to find autocovariances using autocovariance generating method, using this one, this method. Then and compare with what we got there. Okay, let's go to the example for real numbers now. Okay, let's say example. Let's say you have got this process equal to zt plus 0,5 zt. So I want you to go and find and check whether this process is invertible or not. Remember, this is a moving average of order 1. Okay. If the question says identify the model or identify the process, if it's like this one, it's a moving average of order 1. So now is invertible. Okay, that's number A. Number B, find the ACVF, autocovariance functions, and ACF, autocorrelation functions, for XT, for moving average of order 1. That's number 2. Number 3, we are going to plot the autocorrelation function graph. Those are the three things that I want you to do. Then when you have done it, we're going to go through it and check whether what you did is correct or not. So, but anyway, in the meantime, check whether the process is invertible or not. If it's invertible, you have to give me the reason. Why are you saying it's invertible? If it's not invertible, you tell me the reason. Why are you saying it's not invertible? Okay. I'm giving you 2 minutes to identify. 12, 17, you are going to check whether you did it right or not. Giving you two minutes. Well, we are left to just to do number 8. If you're done with number A, so you can go to B. But for now, I just want you to do only A. So we are left with some seconds. Time up, 12:17. Anyone who's having a solution?
It is
Is it
invertible,
invertible?
sir. It's invertible, sir. Since theta 1 is 0.5 and theta 2 we don't have, which is 0. So it's invertible.
Okay.
It
So
suffices
theta
the
1
three
is less than
conditions.
1.
Yeah.
Oh, yeah, you just find one condition because it's only one thing, one value. It's only one value
Okay.
here, or one parameter. So that
Yes.
means you have to find theta 1, whether it's less than what? 1. So in this case, you are saying is what? Theta 1 is what?
0.5.
0.5.
Then it's less than 1. So obvious 0.5 is less than 1. Therefore, the process is invertible. The process is invertible because the absolute value of theta 1, which is equal to 0.5, is less than 1. You get the what you call? The reason. Did you get the reason? The process xt is invertible since the absolute value of theta 1 Do you understand why I'm including minus 0.5 there? No, but anyway, you will find out when time goes on.
Yes.
But anyway, the issue is the process is invertible. Okay, it's fine. Now let's go to number B. Find the autocovariance functions. Autocovariance functions. I'm giving you 12, 19, 3 minutes. 3 minutes to answer number B. So 12, 20, 21, 22. 12, 22 should have done. By 12, 22, you should have done. So just do it. So for number A, you can use this method or the other one for finding the backsheet operator. Then you find whether the factor B or the value of B is outside the unit cycle or not. So if you are using
So what
that
did you
other
say?
method to find number A, yes,
What did you say?
I'm saying for number A, if you want to use the other method of writing the process in backshift operator, and then from there you equate it to 0, and then you find the value of B, and check whether is it outside or inside the unit cycle. So obviously it's going to be outside the unit cycle, and therefore the process is going to be invertible. So all those answers, whether you use the second method or the first method, the answers must be the same. I'm just referring to those who are using the other method. I think your B is equal to what? Because in this case, you're going to have 1 plus 5D, which is equal to 0. So B equal to minus 1, 0.5. Minus 2 is outside the unit cycle, therefore the process is what? It's invertible.
Say.
Yes.
How do you know if
Yes, ask me.
Sir,
Eh?
how do you know if -2 is inside
Yes.
or outside?
Because we're dealing with the unit cycle here. Unit cycle is this cycle. Okay. With -1 here, -1 here, 1 there, and 1 here. That is the unit cycle. So this value B equal to -2. -2 is somewhere here. -2 is somewhere there. So obvious it's outside. It's outside the cycle. So that's why we're saying that it's outside the cycle. The unit cycle. Because it's
So
somewhere
if
here.
it's greater than 1,
If it's greater than 1,
it's outside the unit cycle.
no, don't
I'm
mix
saying
the
for
two
the
methods.
right-hand
If you are
side.
dealing with the first method,
I'm
yeah, if
saying
it's
on the right.
2, let's say for argument's sake, let's say here is not a -2, it's a +2. So it's going to be somewhere here. And again, it's outside the unit cycle as well.
So if it was 0.5, it was inside, ne?
If it's 0.5, the answer. So it's going to be inside. So it will be somewhere, let's say here. 0.5, somewhere here. If it's minus, it's minus 0.5, somewhere here. So it's inside the unit cycle. So the process is not what? It's not invertible. But don't mix the two methods because they are different. Because somebody can take this 0.5 here and use it here in method number 2. It's wrong.
Sir, why do we say ZT is equals to 1?
Why do you say ZT is equal to 1? ZT. Did I say ZT is equal to 1? Hmm? How did you get that one?
When you were
ZT equal
looking
to 1.
for B, sir.
Here. We mean here when you write the backshift operator. Oh, for writing the backshift operator. So isn't that we did that? How do you write the backshift operator? So obvious ZT, because it doesn't have any unit here, any value here. Obvious, when you write it in backshift operator, is going to be 1, then plus 0.5. Here you are having this ZT. ZT is the same as B. Okay, then you close the brackets and write ZT. So this is in backshift operator. I think we talked about that before. How do you write backshift operator? This is how you write the backshift operator. So that is why here we're having 1 here. When you take it back, it must give you this. Okay, it must give you this.
Okay.
That is why we call it a backshift operator. Oh, now you're done with the autocovariances. What is the values now?
So the autocovariance function is given by 1 for k equals to 0, or it actually is given by sigma squared z 1 plus, in bracket 1 plus 0.25 for k equals to 0. For k equals to 1 is 0.5 sigma squared z. For k greater than 1 is 0. The other one, the autocorrelation function is given by 1 for k equals to 0, 2.5 for k equals to 1, and 0 for k greater than 1.
Is everybody getting the same thing? So here you said, and then
No, sir. Okay.
can I write it nicely here? Gamma k, you're saying is equal to
I said it's sigma. Oh, I said 1.25 sigma squared z.
Yeah, yes.
Yes, for k
For
equals
k
to
equals
0,
what?
0.
The
Then is
one,
0.5 sigma squared z for k equals to 1.
So this is 0.5 sigma squared z.
Yeah. Then for is 0 for k greater than 1. Otherwise.
Oh, otherwise, yes. So is everybody getting the same answer?
Yes,
Are you getting the
I
same answer?
got
Okay.
that one.
Okay, now
I also got
what
that
about,
one.
okay, what about the autocorrelation function?
It's 1 for k equals to 0. Then 2.5 for k equals to 1 and 0 for k greater than 1.
For k equal to 1 is what?
It's 2.5. 2.5.
2.5.
Then the other one is 0.
2. That one is 0. Are you getting the
Don't
same answer,
comment.
guys? Are you getting the same, or
Yeah,
you are not writing? Eh?
as it is the same.
The same. Is it necessary to recalculate? No.
Sir,
Yes.
how did they get the 2.5? Because I'm getting 0.4.
0.4.
Yeah, I got
Yeah, I think you are
0.5 as
right.
well.
This is wrong. This is wrong. Because here you have to find row 1, isn't it?
Yes.
Which is gamma 1
It's
over gamma
2.4.
0. Gamma 1 is what? 0.5.
1.25.
So 0.5 divided by
Oh, yeah, mistake. Ish.
1.25.
Oh, thank you.
The answer is 0.4, isn't it?
Yes, sir.
Yeah.
Yes, that's the correct answer. So this one is
Mm,
0.4.
it is.
But the rest is okay. This one is 0.4. Eh? Come again. Okay. Okay. Now you got your autocovariances and the autocorrelation function. So now let's draw a graph. The autocorrelation function plot. Okay, let me just go to the next page. You're still writing.
Not the first. Messenger videos. Where are this one? Here 0.5. Oh, difference the first and second. You got more question back like first.
Hey guys, can you mute your mic, please? One, 2, 3, 4, 5. Hey, can you please mute your mic? Okay, now to draw your autocorrelation function plot. So the y-intercept represents the autocorrelation function at like k, okay, and the horizontal line represent leg k, okay. So in other words, here you are having leg 1, leg 2, leg 3, leg 4, leg 5. So if k equal to 0, this is a 0. K equal to 0, so we have got what? 1, isn't it? For autocorrelation function. So you draw it like this. You go down. It's when k equal to 0. But if k equal to 1, autocorrelation function equal to what? Let's say this one is 0, this one is 0.5. Okay. And if k equal to 1, so we have got 0.4. So let's assume that 0.4 is somewhere here. Okay. 1 is here. So you just draw this line. So you have this one, this one. So this is your peak. This is your peak. Okay, let me just use another color so that you can see it. This is your peak. If k equals 0, this is what you have. If k equal to 1, this is what we have. If k equal to 2, we have 0, isn't it? K equal to 3, 0, and so on. So this is how you plot the autocorrelation graph. And remember, autocorrelation functions must not be greater than 1. It's like probability. I don't want to see your answers to be 1 comma something when you are referring to autocorrelation functions, or 2 comma something, 3 comma something. It must be less than 1 or equal to 1. Okay, so this is your plot of autocorrelation function. I think we are together. Let me just give you another exercise for you to do. Let me just give you this one now. I done. This one is an AC. Let's see now. This is an ACF plot. For what? For XT. Now, can we go to the other exercise now? Exercise. Let's say you have got this time series xt equal to zt plus 5/2 zt minus 1 plus, or minus, sorry, minus 3/2 zt minus 2. We have got this one where z is a white noise with mean 0 and variance sigma squared z. So the question says, number A, determine whether xt is invertible or not. That's number one. Number two, find ACF and no, not ACF, but rather ACVF. CVF and ACF for XT. Okay. Number C, you have to plot. Draw ACF plot. So those are the things that I wanted you to do. Let's start with number A. Find whether this process is invertible or not. For that, I give you 4 minutes. 12:40, you must be done. Second one, give another 4 minutes. 12:44, you must be done. The last one, giving another 4 minutes. 12:48, you should be done. Then the last 2 minutes is for giving you the correct answer if you didn't got it right. If you fail to get it, we have 2 minutes to clarify. So you have 4 minutes to find A. But if you are done, just continue to number B and then number C.
Sir,
Yes.
you know that we were supposed to knock off at 12:40 because you didn't give us a break. Have you noticed
You guys,
that?
you want to learn or you just...
I'm not fighting.
No, I know, I understand that you are not fighting, but that statement make me to conclude something. So you are left with 2 minutes to find number A. If you are done, it's fine. Just go to number B. So you're left with a minute to find number A. Number A, so time's up. Is it invertible? Yes or no?
No.
Anyone?
No, it's not.
It is not. It is not. It is not.
Yes, it's not invertible. Reason?
Morning, sir.
All the conditions are greater than what?
Sir.
Oh, okay. Which method you use the first one? The one for conditions.
Yes, sir.
First method.
Oh, okay, fine. Because if you use number 2, the second method, B is
Sir,
called what?
sir, when I use the second method, I get,
Oh, okay, B equals what?
sir,
Yes, you're supposed to have 2 values. B equal to
yes, value of B is -1.
-1.
Yes, the other one is 3.
B equal to 3. Yeah, obvious, this one is not invertible, but I don't think this is the correct answer. Is there anyone who used second method?
Yes, sir.
What did you get?
I got my roots as -2 and 1/3.
-2 and 1/3. Is not b equal to 2 and another one is -1/3? Because in my case I got b equal to -1/3 and 2. Can you check it? I got this and 2.
Sir, can you show us how you found -1/3 and 2?
Okay. Okay, let me just go there now. Okay, xt, let me just use this one. Xt is equal to zt plus 5/2 zt minus 1 sorry, minus 3/2 zt minus 2. Okay, so now I just want to write this one in backsheet operator, isn't it? So I'm going to get 1 plus 5/2 b 3/2 b squared, then zt. So this is a backsheet operator of that process. Okay, then after writing this one, I take everything within the brackets. This implies that 1 plus 5/2 b minus 3/2 b squared is equal to 0, isn't it? So this can also be written as 2 plus 5b minus 3b squared. Do you agree?
Yeah, that's why I said that's why it gives you the roots that are not the
Now,
same as mine,
this can
because you
also be
took
written
everything
as
to the other side.
3b squared minus 5b minus 2 equal to 0, isn't it? Then from there I find the common factors. I find 3b plus 1 and then b minus 2. This is what I got. Again, if you take this one and this one, is going to be b. This one and this one is going to be minus 6b. So then you get minus 5b. So if you take the minus 2 and 1, it's going to give you minus 2. If you take 3b and b, it's going to give you b squared. So here now, my b is going to be minus 1/3. B equal to 2. You get how I got it? So anyway, you can compare mine and yours and check which one. Whether, but this is what I got.
Say that one, that the method of taking the equation to the other side is the one that leads to the roots of b being -1/3.
You were supposed to get
b
the same
being
answers.
2. But if you take everything and without taking everything to the other side and solve for the roots are not the same. 2 is the one that is negative and 1/3 is the one that is positive.
Okay, but that one doesn't change anything. As long as these roots, okay, let's say according to you, you got this one and this one. Okay. Now the question is, are those two roots outside the unit circle?
The other one is
Remember,
inside and the other one is outside. So
yes, therefore the process is not what? Invertible.
Invertible.
It's not
So which is
invertible.
the same as the first method, isn't it? No, no, it's fine. It's okay. That is the conclusion. So now, can we find the autocovariances? It's too long, this one. No, no.
Yes, we
Is there
can.
anyone who calculated that one? Yes. The answer is what?
Sir,
Hmm.
sir, we can. It's
Yes,
not
you
too
are
long.
listening.
Actually, you just generalized the autovariance for xt. You just then generalize for xt
No,
equals to zt theta 1 zt minus 1, then theta 2 zt minus 2. So now we know our theta 1 is 2.5 and our theta 2 is negative 1.5. So we just have to substitute 2.5 and negative 1.5 on our final generalization of that xt that we did in the beginning. We just have to substitute theta 1 by
So
2.5 and the other one by negative 1.5. For the first one,
I
for
need
k equals
the final solution.
so k equals to 0, I
What?
get 9.5 when I substitute.
9 over 5. Sigma squared
It's
z.
9.5. I get
For k
9.5
equals to.
sigma squared z. Then
Okay. The next
for k equals to, let me see,
1.
1
1.
1 minus 1.5. Or I get negative 1.25 sigma squared z.
In terms of the fraction, because I use the fraction myself here.
In terms of the
You said
fraction,
you
is
get what?
negative 5
Minus?
over 4. Negative 5 over 4.
Yeah, yes. That's true. That's
Okay.
true. That's what I
Then
got.
for that other for the other one, you are going to get, let me
K
see.
equals to.
Is that is that negative 1.5 sigma squared z for k equals to 2? Negative 1.5 sigma squared z. Then is 0 for otherwise.
Okay. Here you get
Is it correct, sir?
minus 3 over 2. Yeah. Those two, they are correct. This one is the same as minus
Correct,
1.5.
Mr. Manga.
Yeah.
K equals to 2 and 0 otherwise. No, the first one is
Yeah.
where we differ. This one, the first one where K equals to 0. Myself, you said you got 9 over 5 sigma squared z, isn't it?
No, I got 9.5 when I substitute. I just
Oh,
I just said
9.5.
I just said 1 squared plus 2.5
19 over
squared
2, sir.
plus negative 1. I just said 1 plus 2.5 squared plus negative 1.5 squared. I get this 9.5. Actually, there you can see
Yeah.
for
Remember,
gamma for 0. See, can I speak, say, for
No, it's
gamma 0
19.2, sir.
yes.
it's 19, yeah, it's 19. Oh, okay.
It is
Sir, but your
Manga,
It's
answer
but
19
in
is
over
not the
fraction
2.
same
it's
as
19
his.
over 2.
Oh, 19 over 2, yeah, right, Clemens.
Eh?
Yeah, 9.5 is 19 over 2, say. Clement is right.
Yes. That's
Yeah.
So that is the answer. 19 over 2 minus 5 over 4 minus 3 over 2. That's the answer. Okay. Conversion functions. Find the autocorrelation for me.
Okay, for the...
Okay. Obvious. K equal to 0. 1 equal to 1. Autocorrelation functions at leg 1. It's 1 for K equal to 0. Row 1 equals what? You can just give me in terms of decimal places anyway. Are you still there? Sorry. K got 1 according to me. And And the next one, I got minus 0,158. Okay, equal to 2. And 0 are the ones. Hey guys, are you still there?
Yes,
Are you
sir.
getting this?
Yes.
Okay, so that's the
Yes,
one.
correct.
That's the one. Then from there, to draw the plot is simple. Just go there and draw your plot. So 1, 0, 1, 2, 3, 1, 2, 3, like K, row K. Obvious this one. This one. Then K equal to 0. So you're going to get something like this one. And this one for 2 is supposed to be bigger than that one because it's 158. And the rest is zeros. You know why are we putting them below? Because we are dealing with the negative here. All of them are negative. There's negative 0,132 and negative 0,158. So this one is negative 0,132 and this one, this is negative 0,158. So that's why we're having this peak, this one, and this one. The rest are zero. So that's it. Let's stop here. We're going to have tutorials, isn't it? Yeah.
Yes.
Yeah, at 10 to 3. Sorry.
Yes.
So yes, yes. Ask your question. Any question?
Sir, can you hear